Good afternoon, everyone. Thank you for coming to this webinar. We have Dr. Vincent VanBuren here. He earned his PhD in molecular biology from Lehigh University in 2022, in 2002, focusing on computational modeling of microtubules. He completed postdoctoral training in bioinformatics at the National Institute on Aging in 2006, where he supervised the assembly of a large cDNA library from early mouse embryos and embryonic stem cells. Joining Texas A&M University College of Medicine in 2006, he served as director of the microarray core facility until 2008, and then as director of the computational biology and bioinformatics lab from 2009 to 2014. He became instructional associate professor of medical education in 2023. Dr. VanBuren has chaired and served on multiple graduate committees, authored 25 peer-reviewed articles, one book and 4 book chapters, and was a keynote speaker at the 2008 Rocky Mountains Bioinformatics Conference. He directs graduate courses in bioinformatics and biostatistics, lead the evidence-based medicine course and AI with clinical application elective, and has held several leadership roles, including chair of the Faculty Advisory Committee and Faculty Ombudsman at the College of Medicine. Dr. VanBuren, we are happy to have you. Please, all various words.
Thank you. Thank you for that introduction. So I'm going to talk to you today a little bit about my thoughts and experiences with AI in medical education and medical biosciences education. And I just wanted to sort of highlight where I interface with the use of AI at the College of Medicine. So I am doing some educational research using AI, trying to predict medical school outcomes, like whether a student will be likely to struggle or not, course outcomes like course grades and progress reports, and then licensing exam outcomes. So that's an area of research that I'm really interested in. I serve on our admissions committee, and I chair a subcommittee that's leading that effort. Beyond that, we'd like to get some data about what happens to our medical students after they graduate, and perhaps extend the model in that direction to see post-graduation outcomes as well. I'm active in teaching a lot of kind of quantitative biology courses. So I teach evidence-based medicine in the medical school. These are all the courses that I direct and teach. So I direct and teach evidence-based medicine, a new elective on AI with clinical applications, also in the medical school. And then in our graduate program, which serves master's students and Ph.D. students, I teach biostatistics and bioinformatics. And I also serve on a kind of working group that's led by our dean for the integration of AI into our curriculum and policies at the College of Medicine. We've recently renamed that as emerging technologies to be a little bit more inclusive of some other things like genomics. So that's been a nice learning experience for me, because we've had opportunities to meet with lots of people in the AI world, and had some opportunities to go out to Boston recently to meet with some people at Brigham Mass General's School of Medicine at Harvard, and some other folks at Innovation meeting up in Boston. And I'll just start by kind of giving an obligatory case example of the use of ChatGPT on licensing exams. So this was something that was published early on in something called medRxiv. So it's a sort of published before you get peer review kind of platform. And this was back in 2022, and if you remember, uh, November of 2022 is when ChatGPT 3.5 first was released to the public. And what you can see from these graphs are the different licensing exam results that were obtained using that version of that very early version of ChatGPT. Uh, and you can see that uh, on each of the different step exams, the pass range is shown with this light blue area here, and you can see that there was either accurate results or intermediate accuracy results for questions in that up to that range. So basically what this means is that even the earliest version of ChatGPT was either passing or close to passing the different licensing exams for doctors. So that's a pretty impressive start. And what we can see in more recent versions across different kinds of tests are that it's that ChatGPT 4 or ChatGPT 4 with no vision are performing at pretty high percentile rates compared to other test takers for a variety of things, including the bar exam, which it's coming in like around the 90th percentile. LSAT also around, maybe like 87th percentile or something like that. All these AP exams, or it's coming in at very high percentiles, like 80 or plus. So clearly, these large language models are really good with handling knowledge bases, and it does lead us to question, what is the value of higher education when everyone has this kind of information at their fingertips. So it's not so much a question of, is ChatGPT going to take these tests for someone? It's not a cheating question. It's more like a question of what are we serving the students in higher education now when this kind of knowledge is readily available. I want to take a more expansive view of AI than just ChatGPT. So ChatGPT and other large language models are the most visible thing right now, right? That's the hot new thing when it comes to AI research, and it's, to be honest, it's had a probably more obvious impact than other types of AI that have been developed in the past. But really, there are so many different ways that AI is being used that other kinds of AI make up the large unseen part of what exists in AI today. And so I'd like to give a kind of brief intro with that broader perspective in mind of what we mean by artificial intelligence and how it's been used in other ways. So I would define using artificial intelligence as using computers to perform tasks that normally require human intelligence. And so traditionally, this has been kind of divided up into notions of weak AI, which is a specialized and limited to specific tasks kind of AI, and then strong AI, which represents human level general intelligence and consciousness, which is just a theoretical goal at this point. Although some might argue that we're pretty close when it comes to generative AI. So generative AI is going to focus on creating content, often with impressive human-like characteristics, but it doesn't possess general intelligence or consciousness. And I think it's clear that it doesn't possess consciousness. Whether or not it possesses general intelligence, I'll remain a little squishy on my answer to that. But in terms of being able to operate just as a human does, it's not quite there yet. So I'll leave it at that. Now, AI is built with machine learning and rule-based processes, and really the earlier forms of AI were really pretty reliant on these rule-based processes, and I'll give an example of that in a moment. But there are various kinds of machine learning that are used in AI, and the one that's sort of risen to prominence is the the idea of using deep neural networks. So what do we mean by machine learning in general? Well, I think machine learning is just statistics. So it's using statistics to make inferences that can be then used in application. And so I think that that's what really differentiates machine learning from AI is that the machine learning is for the learning end of it, right? So it's for building models from data. And so AI is concerned with using computers to perform tasks that typically require human intelligence. So that's the application side. So machine learning is a subfield of AI, and everything that we think of as AI now is really pretty dependent on having machine learning models that underpin what has been learned in those models. Uh, and AI can also incorporate other non-machine learning techniques, including rule-based approaches. And so, when it comes to, let's say, prompt engineering, when you submit a prompt now, there may be certain rules that it passes through before it actually goes to the AI model. Some of those rules might involve helping to ensure that you stay on sort of ethical between the ethical guardrails, I guess, of not producing content that would be objectionable, offensive, illegal, right? So there might be some rule-based implementations here or kind of agents that operate in conjunction with the AI models. So the kind of AI that's being used by large language models is not something we're going to get into. I'm not going to discuss that in detail, but it's something called transformers. But those kind of models are based on something more generic called neural networks. And in classical neural networks, you have an input layer. These are the data that you know, and an output layer. And so we can think of this as a training model, right? So we know some inputs, we know some data about something, and we know some outcomes that have been measured. So the deep learning models contain multiple hidden layers, and the training process is giving the input layer multiple examples, and every time it gets a new example with its known outputs or labeled outputs, these connections in between the nodes, which represent activation functions, they're each parameterized, right? So there's a parameter that basically says when you have an input here, what is your output in the next layer? And so the idea of training a model to best predict your outputs given a set of inputs tweaks those parameters for each of these functions, and it does that through a method called backpropagation. And basically, by giving it many examples of inputs with their corresponding outputs, you can train a model that becomes more and more accurate, right? So you tweak it in such a way that you follow a kind of gradient descent that optimizes each of the parameters for these connections to get the best output. And so there are more complicated versions of this, including convolutional neural networks for doing this with images, and then transformers, which are a fairly recent kind of discovery in 2018, that are the basis. So transformers are the basis of of these large language models that are being used, like ChatGPT and Claude and others. So stepping back in time a little bit, in terms of some landmark things that have happened in the public with respect to AI achievements. So in 1997, this is Garry Kasparov walking away in frustration after resigning Game 6 of his series with Deep Blue, which was a computer that kind of built by IBM to play chess. And this was an example of a time when most approaches to AI were heavily rule-based, right? So this was a kind of computer application that would brute force look at board positions and changes in those board positions based on legal moves, and then give assessments for those future board positions based on a set of rules that they developed with the help of many expert chess players. So a lot of human knowledge went into building these kinds of models. And what we see later on, IBM Watson was developed and then used to play Jeopardy. This was kind of a more, I believe this was more of a deep learning kind of approach to using AI. But in Jeopardy, you're asked to provide a question given some answer, and this is kind of a straightforward problem of trying to use knowledge bases and databases to sort of synthesize a discrete response given some information. And so here you can see, the final question in a Jeopardy that was held with Watson and two Jeopardy champions, Ken Jennings and Brad Rutter, in 2011. And you can see, that they all got the correct final Jeopardy answer, but IBM Watson won that handily with the highest amount of money here. And if you can't read this comment by Ken Jennings, it says, "I for one welcome our new computer overlords." Right. So so he's kind of realized at that point that he had already been beaten by this machine. And I think the most recent of these kinds of public defeats in areas that sort of championed by humans previously is the game of Go. And for many years, people thought that Go was going to be something that computers couldn't beat humans at because of the combinatorial complexity of it. It's much more combinatorially complex than chess is. And this was actually in Asia. This was bigger than the Super Bowl. I think it was something. I can't remember how many millions of people watched this, but I think it was like something over 300 million people were tuned into watching this across Asia, because Go is a very popular game there. And this is this defeat by AlphaGo. AlphaGo represents a pretty big leap in the way AI was applied, where it's basically untrained by humans, and instead it is given a set of rules to follow. It knows how to play Go, it knows the rules of Go, it knows what a winning situation looks like on the board, but it doesn't know any strategies. And the way it learned strategies was by playing games against itself. So it would play games against itself and realize, okay, that's a bad move, and then learn from that. So it had a deep learning model built into it based on its own exploration of the game. And so this was done previously with chess too, which I haven't talked about, but the chess version of this completely outstripped previous software efforts. So this was by a company called DeepMind, that was purchased by Google. All right, so I want to transition to my thoughts about generative AI. So that was kind of like the expansive view of what AI is about. My thoughts about generative AI. One of the things that contributed to my thinking about this is this fairly recent paper in the Annals of the New York Academy of Sciences, and its title is Generative AI and Generative Education. The main points I think that this brings up resonated with me, and I think the sort of these early points are sort of the highlighting points here, which are higher education needs to adapt to AI integration, right? We need to think about how the needs of our students have changed based on the existence of things like ChatGPT. And around that idea, we should redefine our educational goals. The introduction of AI poses a philosophical question about the purpose of education, which I alluded to before. And there's been a shift in diploma value, right? So AI will challenge the current value of diplomas, especially undergraduate diplomas, sort of in sort of narrow fields of knowledge, where that knowledge base is now of questionable value since it's become more readily available. And some of the directions that the author points us in are to focus on public problems. So the relevance of education will be increasingly judged by how it equips students to address public challenges, and encouraging hybrid workflows, right? So using both your knowledge and your mastery of a subject in combination with AI. And this is something that I've heard over and over again in different disciplines, is not that lawyers are going to be replaced by AI, but lawyers are going to be replaced by lawyers who use AI, right? So lawyers who don't use AI are going to be replaced by lawyers who do use AI, and so on. You insert your field there, right? So that's the new world that we live in, is that we need to think about how to best equip our students to thrive in this new landscape. So my personal advice from experiences in my classes are: ask what students need, to learn to be competitive today. Higher ed needs to be responsive to those changing needs. I see AI as making things easier. So instead of forbidding its use in my coursework, I try to think about how can I raise the standards, right? So if it makes producing competent work easier, let's raise the bar of what we mean by competency. And so, like I I'm a little resident to use the calculator example here, because I know it's something different from a calculator, because it can actually explain things, and it can write cogent essays and so on. But it is a tool that has become ubiquitous in a very short amount of time. So in that sense, it is like a calculator. So we don't forbid the use of calculators. We don't ask people to cite the use of calculators. So I think in the short term, it does make sense to ask students to cite their usage of it. But I think that's more interesting to me as an educator, to see how they're using it, and to see how we can use it as a tool to increase their learning instead of a substitute for learning. Ask your students to use AI for a task, then ask them to assess the results. That's a kind of easy way to integrate it into what you're doing in your class in a way that helps keep them thinking about things and contributing their original thoughts. And if original thought and learning objectives around writing are really important to your course, I think that we need to think about how we flip our classrooms better and do the in-class assessments in a manner that that we can do. If we need a student to write an essay and we need them to be completely original in that essay, then let's make them do it in class and figure out how we can flip our material so that if there's lecture content or some other content that can be done outside of class as a kind of homework. And I think surveying your students directly about their perceptions is really helpful and helps I think you grow as a professor uh, to understand what their anxieties might be around this, because we have anxieties. I have anxieties about it. You can imagine what their anxieties might be, right? Where they're just coming into higher education not knowing what their future profession is going to look like. So I think asking students about their perceptions and what they think is important can help shape your own educational priorities. So I have a little bit more. I've already gone way over time though, so I'll just say that I gave some examples here of student perspectives. I can share these slides with you. This is not so important. This is specific to medicine, but these are just some examples of asking my students questions about AI and asking them what they want to learn more about, for example. So and they gave some good responses there. I developed an elective on AI for medical school, and in medical school, our courses are very compact. So when I have them for a week, I am the only person that has them for that week. And so I developed a 4-week elective. The first part has been piloted already, for AHI for healthcare leaders using this book. And there's more to it. And so they can go all the way up to coding if they choose to do so, right? So they can have an experience coding their own projects, maybe like an image analysis project to try to classify chest X-rays or something like that. So that's something that we can work on together to help them develop their own personal project that touches on medicine. So with that, I will open it to any questions and discussion that you have.
All right. Thank you so much, Dr. VanBuren. Any questions from participants here? Meanwhile, I will stop the recording.